Hello, welcome to our program, Astronomy for Everyone. Every year, the Ford Amateur Astronomy Club has a banquet. And one of the features of that banquet is where we hand out certificates of appreciation for the work that the various club members have done throughout the year. Well, with the first anniversary of our program upon us, we felt it was important to recognize the crew here at the studio who helps us bring this program to you. With me here in the studio is the Ford Club president, Doug Bauer. Doug, welcome to the program.
Yeah, appreciate it.
I understand you have some certificates for our crew members.
I do, yes. As everyone may not be aware, that it takes a lot of people to put a program like this together. So we just wanted to say thank you to the crew from the Wyandotte Municipal Cable System that are working with our Ford Amateur Astronomy Club to put this program together. First, I'd like to thank Barb Bradshaw.
Thank you.
Barb is responsible for the audio portion of the program. And also Rick Elby, who can't be with us today, but Barb's going to see that he gets his certificate. Thank you.
Thank you.
Also, Kirk Walborn. Kirk, thank you. Operating the camera. We have some stand-ins right now. We're doing that. And Dan Hernandez, also doing camera work. And Amy Candatella. There you go. Thank you, Amy. And we also have one for Steve, who's the studio program director. He's off today, too.
I'll give it to him.
Additionally to the Wyandotte crew, we gave certificates to the Ford Amateur Astronomy Club members who have also participated in this. And as you've been introduced earlier, Don Klaser, John Schroer, Ken Anderson, Steve Whitty, Kevin Meaden, and Lori Poromsky. They all are part of our on-air talent or back in the studio putting this production together. I want to thank them all, and I really do appreciate the work, and I hope you're enjoying the program. Thank you.
Thank you all.
Thank you.
The nearest and most opulent stellar factory resides 170,000 light years away in a turbulent star-birth region called 30 Doradus. Many of the diamond-like blue stars are among the hottest and most massive stars known. The brilliant stars are unleashing a torrent of ultraviolet light and hurricane-force stellar winds that are etching away at the hydrogen gas cloud in which the stars were born. The nebula is close enough to Earth to give astronomers important clues about the birth and evolution of stars in the universe.
Welcome back to our program. A lot of times people will ask me, where do the constellations get their names, and well, where do those stories come from? Here with me in the studio is John Schroer, a member of the Ford Amateur Astronomy Club, and we're going to talk about just that very subject. John, welcome back to the program.
Nice to be back, Don. Thank you.
People wonder, where do these names come from? Why do we call a certain constellation by that name, or where does the story come from behind it?
Well, constellations, you got to remember, more than 3,000 years ago, there wasn't cable TV, there wasn't the internet, no game systems, no TV or radio. So for the evening, people hung around the campfire, and some of them noticed those little twinkling lights in the sky that we call stars. And they looked at them night after night, and they decided that they would try and invent dot-to-dot pictures out of them. And that's where the first constellations came into being. The oldest one is Auriga the Charioteer, and that was named by the Sumerians, one of the first early great civilizations on the Earth. It was located where modern-day Iraq is today. It's seen in the wintertime. So most of the constellations were invented by people around the Mediterranean. The Sumerians, then later on, the ancient Greeks. The Romans, when they conquered the Greeks, renamed them with their own language. And then that was carried over until the Europeans began to take science seriously about 400 years ago. And they began to create constellations where no one had before, mostly located in the southern hemisphere.
They took the stories that they were familiar with, their gods, the animals around them.
Or heroes.
Or heroes, and put the pictures up in the sky, connecting the dots, as you said. Why don't we start out in the northern sky?
All right. Now, the northern constellations are the easiest to find and the easiest to see because they're up all the time during the year for people living here in Michigan or in the Midwest. First constellation we'll talk about will be Ursa Major, the Great Bear. It is the largest constellation in the northern sky and one of the largest in the entire sky. Now, inside of Ursa Major is probably the brightest and best known of all the star groupings that have a common name, and I'm talking about the Big Dipper. 4 stars that make up the handle 3 stars. I'm sorry. All right, there are 4 stars in the cup, and there are 3 stars that form the bent handle. The 2 stars at the end of the cup, the top one being called Merak and the bottom one called Dubhe, if you follow that line from the bottom of the cup through those 2 pointer stars, they'll guide you to the North Star Polaris. Ursa Major will then show you the way to Ursa Minor, or the Little Bear. Now, the Little Dipper starts with the North Star Polaris, which is not the brightest star in the sky. People had this strange opinion that it is the brightest. It's actually about the 42nd brightest star in the sky.
But it is placed almost exactly over the North Pole of the Earth.
Yeah, it's about 0.6 degrees away from being right above the North Pole, but as many people say, it's close enough for government work.
There you go.
The only other stars that are visible are the 2 stars at the end of the cup, if you live near the city. The brightest of the 2 stars is Kochab. It's labeled with a strange-looking bee you can see on the screen. Now, because Polaris is the North Star, if you were to watch, let's say, the night sky in wintertime in Alaska, you would watch the Little Dipper completely circle all the way around the North Star, as well as being able to see the Big Dipper as well. Now, the third constellation that most people can easily see from the city is Cassiopeia the Queen. And she's best discovered by looking for a lazy W in the sky. It'll be on the opposite side of the sky, of the North Star, I should say, from the Big Dipper. And you'll see its famous and rather bright lazy W shape. Now, as I explained to many school kids, how they came up with a beautiful queen sitting on her throne while she's looking at herself in a mirror out of lazy W stars, I don't have any clear clue on. But that's what it's called. In fact, Cassiopeia, if you're out in the dark country sky, you'll see some soft glowing light, almost like a very transparent cloud behind it. And that's actually because it's sitting inside the Milky Way, the thickest part of our galaxy. And what you're seeing is the glow of many stars that are too far away to be seen by our own eyes. But if you take a binoculars or a telescope, you'll be able to see a lot of the stars in the Milky Way.
And so these 3 are the 3 primary constellations of the northern sky?
That's correct. Those are the 3 bright ones. Other constellations in the northern sky include Cepheus the King, the husband of Cassiopeia. His stars are not nearly as bright as Cassiopeia, and they look like a little house. And then there is the little-known Camelopardalis, and that is the giraffe in the sky, and nobody ever talks about him because he has no bright stars.
Well, let's not forget our Harry Potter fans out there, John. We don't want to forget Draco.
That's right. There is Draco the dragon, who kind of slithers between the big and the little bears.
Well, we hope you've enjoyed this conversation about the constellations of the northern sky. Next up will be Term of the Month from Steve Whitty, and then we'll be right back with Part 2 of Constellation Lore. Stay tuned.
The term of the month for July is astronomical distances. Astronomical distances are very large. They're so large that they're very difficult to imagine. Now, when we are very young, we don't actually count. We have to learn to count. And it turns out that astronomical distances, counting is not a very good strategy. What's a better strategy is to think of a small distance and then think of some multiple, maybe 10 times as far or 100 times as far, and compare one to the other as a factor bigger. So you start off with the corner stores maybe a mile away, and then 100 miles away or 100 times farther gets you across the state. Well, in the case of Michigan, it gets you halfway across the state out to Lansing. And then 100, we don't have something exactly 100 times bigger than that. The diameter of the Earth is 80 times bigger. It is 8,000 miles. Just 30 times bigger than that is the distance to the moon, 238,000 miles. And then 400 times bigger than that, farther than that, 93 million miles, is the sun. And we also call this 1 astronomical unit. And as a side note, it takes light about 8 minutes and 20 seconds to get from the sun to us. 10 times farther than that, from the Sun anyway, is Saturn. We call that 10 AU, or 10 astronomical units. 10 times farther than that, at 100 AU, is heliopause. This is where the solar wind, particles being emitted by the Sun out into space, meet the intergalactic medium, the interstellar medium, and the pressure from the interstellar medium just matches the pressure of the solar wind going out. At 100 AU, 100 times the Earth-Sun distance, that's heliopause. There isn't a heck of a lot between that and the nearest star, and the nearest star is 2,500 times farther than this sphere, the radius of the sphere, heliopause. At 4¼ light years, or 25 trillion miles, that's a million, 25 trillion miles is Proxima Centauri, our very nearest star. Going out any farther, the multipliers become much bigger, so we'll stop here. And that's the term of the month, astronomical distances.
In the first part of our program, we were talking about the constellations of the northern skies, the ones that we can see really any time of the year. We're going to turn our gaze now to the constellations and star patterns we can see in the southern sky. With me again here in the studio is John Schroer. And John, why is it that we see different constellations facing south where we see the same ones looking north?
Well, the northern constellations we mentioned, the Big Dipper or Ursa Major, the Little Dipper, Ursa Minor, or Cassiopeia, they're all located near the North Star. And it's called that because the North Pole of the Earth is actually aimed close to that star or almost on top of it. So as the Earth spins and orbits the Sun, it's always going to be facing those star pictures, and they're always going to be up in the nighttime sky. Now, the southern constellations change with each season because as the Earth orbits the Sun is in a different place in our sky, and so it slowly changes what star pictures we can see at night. The new stars that become visible rise in the eastern sky, while the ones we have been watching disappear in the twilight of sunset.
All right, well, now here we are in summer, and we want to talk about the constellations of summer. Where do you want to start out?
Well, let's start at constellation that in July is almost at the top of the sky. That would be Hercules the hero. Now, Hercules, by the middle of July, will be almost at the top of the sky, and the easiest way to find it is to look for a small uneven box. This is known as the keystone. It marks the waist and the lower half of Hercules the hero. Now, with a pair of binoculars, you'll be able to see what appears to be a fuzzy star down his right leg. And this is one of the largest gatherings of stars we can see in the northern sky. M13, also known as the Hercules Globular Cluster. Think of it as a giant collection of 100,000 stars in the shape of a large globe.
Is there anything else of interest that our viewers might find in Hercules?
Well, in the way of stars, no. I think M13 with binoculars, and you might be able to see it as a fuzzy star, is probably the most prominent feature of Hercules.
Now, could they see this globular cluster from here in the city, or do they need to go out to a dark country sky?
If you're using binoculars or a telescope, you have a shot in the city. But unless you've got those, your best chance to see them with just your eyes is going to be out in a dark country sky, at least an hour away from any city lights.
Okay, that sounds good. Now, what constellation is next?
Well, the next constellation features the brightest star of summer, and that is Lyra, the musical harp. And Lyra features the bright star Vega. Now, Vega appears to us as a very bright white star. It's about 27 light years from the Earth, which means you're seeing what it looked like in 1983. Another way to think about it is if you had a drive there, and you could drive at the speed of light, about 700 million miles an hour, it would take you 27 years to get there. So it's about 162 trillion miles away from the Earth.
That's quite a distance.
It most certainly is. Now, also in Lyra the harp is a beautiful cloud from a star that has died. It's known as the Ring Nebula, and that you definitely need a large pair of binoculars or a good telescope, and the further out in the country you are, the easier it's going to for you to find it.
And that object is marked by the designation M57?
M57, that's right, at the bottom. Next to the star marked with a funny B or beta Lyrae, which is actually known as the star Chiliac.
Okay, is there a story connected with this constellation? Lyra sounds like lyre or harp.
Yeah, it's named after the harp of Orpheus, one of the best known of all the classical Greek musicians. The story was that he was among the greatest musicians of ancient Greece. The story is told that when his wife was killed in an accident, he used his music and his harp to enter into the place where souls went when they died, the underworld known as Hades, which was ruled by the god Hades. And he played a song for the god that moved the god to tears. And Orpheus received permission to bring his wife back to Earth, but he could not look upon her until he had returned to Earth. So on their journey from Hades back to the Earth, she didn't say a word, and he grew more and more nervous that she really wasn't there. It became overwhelming and overbearing for him, and just before they reached Earth, he turned to look. His wife disappeared back to Hades, and he had lost her until he himself finally died. So because of the power of his music and what he did to try and save the love of his life, his wife, the Greeks put a constellation for him up in the sky and his harp.
Very interesting. What's next, John?
Next constellation we're going to talk about will be Aquila the Eagle. Now, Aquila the Eagle has one bright star called Altair, and you will find Altair at the top. It's actually, in many drawings, shown as a diamond on the collar around the neck of the eagle. Now, Altair is actually the closest star to the Earth that you can see in our nighttime sky, apart from the sun. And it is about 17 light years away, or about 102 trillion miles. It also appears as a whitish star in the sky. The rest of the eagle looks like a kite with a tail. There's not much in the way of other bright stars or celestial objects in that part of the sky.
I do notice from the image that we have up that Aquila also seems to be along the plane of the Milky Way.
That's correct. Lyra lies above the Milky Way. Aquila is in the middle.
What's next, John?
Well, next one will be the third member of what we call the Summer Triangle, and that's going to be Cygnus the Swan, with the bright tail star you can see at the top called Deneb. Now, Deneb is actually one of the most distant stars that you can see in the summer sky. It's about 19,200 trillion miles from the Earth. The reason you can still see it is because it is very bright compared to Lyra, the harp Vega, or the Altair star in Aquila the Eagle. Now, if you're out in the country and have a large telescope, there are some wonderful things you can see in Cygnus the Swan. First, out in the country with your eyes or a pair of small binoculars, you can witness the Milky Way running right through the center of Cygnus the Swan.
I can see it running parallel with the great bird.
Absolutely. Now, if you look near Deneb and to the left, you'll see a designation called NGC 7000. And that is a giant cloud known as the North America Nebula.
Well, why is it called that, John?
Well, it looks remarkably like North America on a map of the Earth.
No kidding.
Yeah, absolutely. Also, near the center star of Cygnus the Swan, there is the first black hole ever discovered by astronomers. It's known as Cygnus X1. It was the first source of X-rays, and that's caused by material swirling around before it falls into the black hole.
Of course, a black hole is an area of space where nothing, not even light, can escape because of the massive gravity of the object.
So you can't see it directly, but you can detect it by the stuff swirling around before it falls in, heating up, and it glows in X-ray light, which we can see in X-ray telescopes.
Now, I know there's also one other interesting star in Cygnus the Swan, and it's the star that represents the head of the bird, and that star's name is Albireo. Can you tell us a little bit about that star, John?
Yeah, you'll see Albireo located at the bottom right corner of the screen. Albireo is actually a double star, one slightly blue in color, the other slightly gold in color. In these parts, it's nicknamed the University of Michigan double star.
Because of the colors maize and blue.
Absolutely.
Now, I know we're going to have some Spartan fans out there, and they're going to want to ask the question, is there a green star out there?
Well, there are no Spartan double stars because stars appear in many colors, but green, unfortunately, is not one of them.
Well, we tried anyway.
Absolutely.
All right, well, you mentioned that Deneb was the third star of the Summer Triangle. What is the Summer Triangle? Is that another constellation?
Well, it's actually an asterism or popular picture made of the three brightest stars: Vega and Lyra the Harp, Altair and Aquila the Eagle, and Deneb and Cygnus the Swan. It's called the Summer Triangle by astronomers in a lot of planetariums that deal with summer camps. It's also been nicknamed the giant slice of cheese pizza in the sky, or the giant nacho cheese corn chip or Dorito in the sky.
The kids like that, I'm sure.
Yeah, because of the triangle shape and something that appeals to them.
So the Summer Triangle is something that would be visible throughout the summer for people to look at
Yeah, whether in your city or in the country, it's visible anywhere.
because of those three bright stars that you talked about earlier.
That's correct.
Also, the constellation of Cygnus has a common name that is known as the Northern Cross.
That's correct. It is much larger than the Southern Cross. The Southern Cross is a rather small group of stars as compared to the Northern Cross. We're now going to follow the Milky Way down to the southern sky, and we're going to check out the next constellation, which features one of the nicest stars in the summer sky. We're going to go to Scorpius the Scorpion. Now, it's located due south shortly after sunset, which in July will be around 10 o'clock or so. And near the top, you will see a star that's rather large, and it's called Antares. It's known as the heart of Scorpius the Scorpion. Now, it's actually red in color, and the name actually derives from the ancient Greek, which means not Mars. The planets, you'll see that dashed line going across the top of the screen. That's the ecliptic, the path that the sun, moon, and planets travel. And on occasion, Mars passes by Scorpius the Scorpion, and some people got confused. Which is the star and which is the planet? And planets you can discover by watching them slowly move from west to east over the course of many nights. So to avoid any problems, they called the star not Mars.
It works.
Yeah, it does.
It works.
Now, if we can bring back Scorpius again, I want to show you in the area around the tail. You're actually looking toward the center of the Milky Way galaxy. If the Milky Way galaxy is a giant city of stars, you're looking towards downtown. Now, there are some nice objects you can see with a pair of binoculars in the suburban or country sky. To the right of Antares, you can see M4, which is a wonderful little globular star cluster. And then there is, to the left, you'll see M22. That's another wonderful cluster. And now we're going to move on to its next door neighbor, and that's going to be Sagittarius the Archer.
That's the constellation that has the teapot asterism.
That's correct. Now, there aren't any really bright stars in Sagittarius, but here you can see that the steam coming out of the spout, is actually the Milky Way. And you can see there are a great deal of M objects in that part of the sky. Like I said, you're looking toward the center, so there's lots of things to look at if you live in suburban or in the country sky with binoculars or a telescope. There is M8 and M20, and that is the M8 is the Lagoon Nebula. It looks like a giant red lagoon floating up in the sky. And then just above it is M20, and that's known as the Trifid Nebula. It's actually two large clouds of gas and dust. One has a faint red color. The other, which is separate and a little more distant, has a blue color to it.
And of course, the M designations are from the Messier catalog.
That's correct.
Of Charles Messier.
Yeah, Charles Messier was a French astronomer who wanted to become rich and famous. And he did that by discovering comets. Royalty and nobility would give you cash, jewels, wonderful prizes if you discovered comets. So he began to look for comets, but he kept running into these small fuzzies in the night sky that he thought were comets, but later on discovered they weren't moving. So therefore he made a list of these objects. We would not mistake them for comets ever again.
I'm sorry, John. This has been a fascinating discussion. If our viewers out there have any questions about any of the constellations or anything else for that matter, send us an email to our email address that you can see at the bottom of the screen. And right after this, we'll be back with What's Up in the Night Sky.
Welcome to What's Up for July 2010. The first phase of the moon visible in July will be the third quarter, rising late at night on the Independence Day, July 4th. The new moon will follow a week later on the 11th of July. The first quarter moon will be on July the 18th. Then the full moon will be on July 25th. We're moving on to the planets, and in the western sky, you'll be able to see the planets Venus, Mars, and Saturn, all in a row to the west after 10 o'clock at night. Also, at the first quarter, you'll be able to see the first quarter moon joining them in the sky. The next planet off will be Jupiter, which will rise about 1 o'clock in the morning. In this image here, you can see the missing southern equatorial belt. Jupiter lost one of its dark cloud bands, which was a great mystery. It happened once before, back in 1973. Mercury will be visible farthest from the sun on the 19th of July, where we'll see it in the glow of sunset. Also in the night sky, you're going to be able to see Comet McNaught, also labeled Comet 2009 R2. It'll be closest to the sun on July the 2nd, only 37 million miles away. It'll be visible also in the glow of sunset in the constellation of Mercury in the northern sky. That's up for What's Up in the Night Sky. Please go out and enjoy the best free show in the universe.